Do you want to know what primordial black holes are and how they could solve some of the biggest problems we currently have in cosmology? Then watch this video until the end. But before I tell you what primordial black holes are, I have to tell you about black holes in general, although you may have heard of them before. Normally, they form when very, very massive stars, much heavier than our own sun, die and collapse into a tiny volume. A black hole with the mass of our sun would actually be just a few kilometers across. The gravity of black holes is so extreme that it bends the surrounding space-time so strongly not even light can escape. This is illustrated by a black hole bending the sheet of space-time here on the right. Hence, black holes are called black. And if light cannot escape them, it is of course very difficult to see them. Well, how difficult exactly? This is a picture taken by the Event Horizon Telescope in 2019. It is the first ever photograph of a black hole captured by mankind. Yeah, it's not very pretty. Would you have guessed that it cost $60 million to get this picture? Well, I think you can see, or not see, why we know so little about black holes. Great. So what are primordial black holes then? Okay, I have to warn you, we know even less about them. They are a different breed, not formed by the gravitational collapse of dying stars, but they still behave in the same way. Physicists think that they come from the very early stages of the universe. Back then, the universe looked more like this. A boiling, bubbling pot of cosmic soup. Well, not exactly, and also here I use water because we physicists really don't get enough money, and I couldn't afford actual soup for this video. Anyway, there are a lot of fluctuations in the soup, bubbles forming and disappearing again. Well, every now and then, the fluctuation becomes very large and a drop of water can shoot out of this pot. How do we apply this to our actual cosmic soup, you might ask? If a fluctuation becomes really, really large, a primordial black hole can form. Just like in our pot of water, there are different sizes of water droplets shooting out which correspond to primordial black holes of different masses. We currently believe that they could be as light as an asteroid or as heavy as the supermassive black hole at the center of our Milky Way, which weighs more than 1,000,000 times of our Sun. So why are primordial black holes so interesting then? Well, we know from a lot of observations that about 1/4 of the universe is made up of dark matter, which is stuff we cannot see. And 2/3 is dark energy, which is also stuff we cannot see. But that accelerates the expansion of the universe. One of the ways of obtaining this number is by analyzing the cosmic microwave background, which is essentially a picture of our cosmic soup around 400,000 years after the Big Bang. Believe me, we have really tried to look for dark matter particles, but we haven't found any yet. We only know for sure that dark matter gravitates and is dark. So, primordial black holes would be a very tempting option of explaining dark matter, the stuff we cannot see, without inventing any new particles. Some recent theories even suggest that supermassive primordial black holes could be the seeds of the earliest galaxies. These were observed by the James Webb Space Telescope, but thus far we don't have a good explanation of how they formed. Even more excitingly, very recent theoretical research suggests that some of the primordial black holes could even account for the dark energy, which we know even less about than dark matter. So, this sounds great and all, right? But how can we know primordial black holes actually exist? We already established that it is really difficult to detect them, but there are some ways. One of them is Hawking radiation. We know that very light black holes evaporate much more quickly than heavy black holes and thus would be very, very hot. So this Hawking radiation could be detected with very sensitive instruments. We can also use an effect called microlensing. When a black hole passes in front of a star we are observing, according to Einstein's theory of general relativity, the light gets bent around the black hole, just like a lens would bend light. So the brightness grows for a short period of time and then falls back to normal. If we observe a lot of faraway stars, we could pick up this microlensing effect. Lastly, if black holes merge, they produce gravitational waves. This made quite a wave when they were first measured in 2015, a full 100 years after Einstein predicted them. If we were to measure gravitational wave signals that could not have come from stellar black holes, this could hint at an exotic, maybe even primordial origin. The bad news is, so far, with none of the methods, we have found any direct evidence of primordial black holes. The good news is, since our experiments are sensitive to different mass ranges, the fact that we did not find any means that we can exclude certain masses of primordial black holes. So we actually have learned something. To conclude, I explained the idea of primordial black holes and hopefully I conveyed to you that they are currently a very, very hot topic, potentially solving the big mysteries about dark matter and dark energy. This is the end of my short presentation, but just the beginning of our quest to understand primordial black holes. Thank you very much.